Hello everyone and welcome back to another tutorial on developing applications for the Canute Scientific. In this tutorial I'm going to be discussing tables. As I'm sure you are all familiar already, one of the major advantages of the Canute Scientific over other similar Braille displays is its ability to display 9 lines of content in any one go. Now this bodes itself very well to working with two-dimensional data over other displays, specifically tables, comma-separated value files or CSV files for short, and all the similar sorts of data you'd be utilizing in applications such as Microsoft Excel, which poses great potential in terms of data analysis, data science, and like-minded fields that are utilized within STEM. The Canute Scientific is very much capable with dealing with this style of data and utilizing it for all kinds of different use cases within the applications that we've already developed and you could potentially develop. We have applications that are capable of generating this sort of data for all kinds of use cases. For example, our YouTube engagement analyzer application can generate engagement data for YouTube channels in CSV formats. This data can then be fed into the console charts application to generate a chart that shows the relationship between video duration and engagement for videos across a YouTube channel, so that those of you who are YouTubers, if any of you listening are, can gauge what duration or video length, generally speaking, yields the greatest engagement and greatest viewer satisfaction for your YouTube content. There's numerous ways in which we can gather data in this format to be utilized with applications such as console charts for data analysis. In its most simplest form, we can create this data manually. If you were to simply open a text editor installed with the Canute Scientific, for example, Micro, you could literally write out data in a CSV format or comma-separated format. If I am to give the name in full, all you'd need to do is, starting at the top, write your column name separated by commas in a tabular form that I'm sure you'd be used to. So have all your field names across the top, and then underneath that, enter all your rows of data values corresponding to those fields. For example, let's say we're creating a table showcasing the trend in rainfall and temperature over a number of years. We may start off in the top left by having a year column for, the current year, followed by a comma. We'd then have a month column, so January, February, March, etc., that corresponds to that year. We then may have, the average rainfall column for that month in millimeters or centimeters. And we ideally want to make sure we're labeling that column as such so that it's clear. Another comma, followed by, finally, the average temperature for that month, again ensuring to include the unit. And then underneath that, we'd populate our columns, separating them with commas, for as much data as we would like to have in our data set. And once we're done, we can save that as a .csv file. We can then import that file into the spreadsheet viewer application that is available pre-installed on the Canute Scientific. It's not an application I developed, so I will be transparent, familiar with all its intricacies, but it does allow you to view in detail spreadsheets and similar CSV style datasets as you would do on the likes of a standard Windows computer. There's also a toggle key to toggle between the standard view and also the formula view for spreadsheets that contain formulas, which obviously doesn't apply in this case. But this is a very comprehensive viewer. It has a help page as well in its menu, so I definitely recommend consulting that in terms of viewing table or tabular data on the Canute Scientific. And of course, the Braille output will mirror directly what's on the monitor. So there you have it, comprehensive functionality to visualize tabular data sets on the Canute Scientific, which, correct me if I'm wrong, but it may well be the only Braille display out there on which you can do that. As I said before, you can also create these data sets programmatically, and you can do that by parsing data utilizing Python, which I talked about Python in the previous installment of this series, where we discussed creating user interface for your applications. You can also parse this data within your applications into what is known as a Pandas data frame. Pandas is a Python package that comes pre-installed with your Canute Scientific. You just need to import it as you do any Python package at the top of your script, and you can utilize pandas, and you can pass any data of any style into what is known as a pandas data frame, be that JSON data, YAML, anything of that nature. There's different ways to go about it depending on the origins of that original data and the type of data, etc. And essentially a pandas data frame is essentially a bit like a dictionary. If you've ever dealt with JSON, it contains keys, and though each key corresponds to a column, and each of those keys contains a list, and that list is just the different entries within that column, corresponding to the different rows in the dataset. So each, index starting at 0, obviously, as Python list indexes do. They don't start at 1, we start at 0, because as far as computer science is concerned, we start counting at 0 and not 1. Each index within that list will correspond to the numerical row in the dataset, minus 1, of course, because obviously we're starting at 0 with those indexes. But you can, with a single method, take that pandas data frame once you got the data in there and save it as a CSV file for use with, as I said, in the likes of applications such as console charts. So it's literally a single method once you got the data in there, and there's plenty of pandas methods to actually simplify the conversion of that data, be that JSON, YAML, etc., into the pandas data frame. So using Python and pandas, it's very easy to get data of any kind into that CSV format in a file so that it can be used for analysis and such like. So again, very straightforward with that one. For example, maybe you create an application using the techniques we discussed in the previous video that enables you to a form or a series of forms that allow you to enter different weather data and compile that all together and convert it to a CSV format, or any use case you could create that sort of application for. I don't know, maybe if you're inputting stock items at a store, that sort of thing, your local, I don't know, supermarket or whatever. There's endless amounts of examples you could try out, combining the techniques we discussed in the previous video surrounding user interface creation, pass all the data you've collected from your user interface into a pandas data frame, and get that all saved off into a CSV. But that brings us to the end of this installment. In the next installment of this series, continuing on from this, and I touched on it briefly, we're going to be talking about JSON data and fetching data from APIs, because not all data you're going to be using in your applications is going to be static data, that's stored on your local hard drive, like your CSV data. We also need to talk about dynamic data, looking at that that's fetched from third-party sources. So stay tuned for the next installment of this, and I'll catch you again soon.